but at least if you can bear with us, at least at most 1 hour, 20 minutes, at most. I'll try to facilitate that. What we are going to have now is presentations on agriculture, and the one that we are having it is going to be presented by Mr. Leswetsa Franz Joseph, who has 21 experience in research. He holds a BSc in agriculture, soil science and agronomy, BSc Hons, and Masters of Agricultural Science, specializing in soil physics. He started working at the University of the Free State as an assistant researcher. He was employed by the Agricultural Research Council for Soil, Climate and Water as a professional development program candidate from September 2007 until 2013. He was also involved in several research projects as a research soil scientist working in the Free State, Eastern Cape and Limpopo and Botswana. So I was just trying to highlight that we have relevant people that are supposed to drive the province forward, and that's exactly what the colloquium is trying to do. At current moment, Mr. Joseph is employed by the Department of Agriculture and Rural Development as a soil scientist, active manager responsible for soil science, crop science, and horticultural science, referred to as Plant Biosystemic Subdirectorate. And he has authored several research projects and reports, scientific papers, and popular papers. He also has been awarded awards during Congress as a main author and a co-author. Let's welcome Mr. Joseph to come and give us his presentation. Thank you very much.
Good afternoon, colleagues. My name is Leswetsa Franz Joseph. I'm going to discuss a rehabilitation of arable and grazing land using cannabis around around diamond and abundant gold and diamond mines. I would like to thank my co-author, Datin Chabileng. My structure of the presentation will be introduction, literature review, aim, material methods, results, recommendation, impact, and conclusion. I must say we are very fortunate province due to conducive climate and high potential soil for agricultural production. And also we are very lucky again, we contribute about 30% of gold to South Africa. We have about 3.2 million hectares of arable land and about 8.7 hectares of natural field. So yesterday it was said if the Free State is still the bread basket of the country, Darren Chabileng will say no. I will disagree with him, and I will partly agree with him until he shows me the stats to say, in terms of dairy production, we were there, now we are here. In terms of livestock production, we were there, now we are here. I'll tell you why I say I also partly agree with him. Yesterday it was said that mining contributes about 11% of the province GDP. And then agriculture also contributes about 9% of our GDP. Having stated that, as much as mining contributes about 11% of GDP, it also negatively impacts on agricultural production. I'll tell you why. Due to heavy metals contamination, mining impacts negatively on the agricultural production. The results indicate that we have contamination of heavy metals around abandoned mines. The heavy metals that I'm talking about are lead. Examples are lead, chromium, arsenic, zinc, cadmium, copper, mercury, and nickel. So in most of this contamination, you'll find this contamination around abandoned mines, because we know mining activities, the process of getting gold, it involves some chemical process before you get the end product. So, having stated that, Machabe and let's say Maine are no exception to this heavy metals contamination. Let's look at the literature. The sources of these heavy metals. Heavy metals are simply the metals that our body needs in very, very low concentration. And the problem with heavy metals, if they are in high concentration, they become toxic to our health. So literature says the sources of heavy metals are from your fertilizer. For example, if you look at the bag of a fertilizer, you'll see some are written 232, and then in brackets there's that 0.1% Zn or 0.5% Zn. It means that zinc we need it in very low concentration. And then worldwide, about 20 million hectares are being irrigated by wastewater. But the negative impact is that in the long run, we have accumulation of these heavy metals in the soil. The third one is biosolids and manure. Application of these biosolids, especially municipal sewage sludge, it leads to, as much as it gives nutrients to the soil, but it also have a negative impact in terms of accumulation of these heavy metals. The fourth one is mining. As I've said, mining activities, before you get that gold, there are various chemical processes that take place, which leads to this accumulation of the release of these heavy metals into the soil. And then how do you remedy this? I've got three. There are various methods, but I've just pinpointed three. I will start with immobilization. This process involves you apply the chemicals, and then those heavy metals cannot be released. It means they are immobile, so that they cannot be released to the plants. The second one is you can use, it's called soil washing. You can use it physically, or you can apply chemicals to wash the heavy metals. And then the most important one that is my main topic is phytoremediation. Phytoremediation, it means you use vegetation to extract those heavy metals into the soil, and then they accumulate into the plants. What is the problem of heavy metals? As I have said, heavy metals in high levels, they are toxic to the plant itself, and also to, let me say, they are toxic to all living organisms. The aim of the study is to rehabilitate heavy metals contaminated soil using phytoremediation. In this case, we are going to use cannabis sativa. The common name there is hemp. Continue with materials and methods. My study areas are abandoned mines around Machabe, in Velcom, Odendals Race, Allen Ridge, Virginia, and in Machabe, yeah, it's Velcom, Odendal, Allen Ridge, and Virginia. And then in Litzemeng, my studies will be at Coffee Fontaine. And then the soil samples were taken at a grid of 100 by 100. I must say, in Coffee Fontaine, we are still going to, we still have to collect the samples. There, my study areas is Allen Ridge, Erindal, Velcom, and Virginia. I must, as much as my topic says abandoned mines, in Virginia I chose one farm where the mining is still active. Why? Because it was found that already the soils are being contaminated by heavy metals. Currently, the farmer is out of business because he's no longer farming. One, he realized that the yields are dropping because of contamination in the arable lands. And then what he did, he continued with the livestock production. Unfortunately, because he was posing health risks to the public, because you must remember the chain is like this. Humans, if they consume the contaminated whatever veggies or what, then those heavy metals builds up in your tissues, and then leading to things like your lung disease, your kidney diseases, and your bone diseases. And then again, if the livestock graze on those contaminated, let's say contaminated plants, those heavy metals will also accumulate in their tissue. And then what happens? You buy meat and then you consume that meat, and then again those heavy metals accumulate in your body. So that farmer, the active mine, is currently not farming. There's a case between him and the mine where he wants compensation. As I've said, the samples were taken at 100 by 100 grids at the following depths: 0 to 100, 100 to 200, and 200 to 300. The reason why I chose these three, because 0 to 300 is topsoil. As an agriculturist, I'm interested in the topsoil because that's where your crop production is taking place. As I've said, it's the most critical horizon for crop production. And then the soil samples were tested for pH, clay, and these heavy metals. pH, in simple terms, is a measure of how acidic or how alkaline the soil is. The scale ranges from 0 to 40, whereby 7 is neutral, below 7 is acidic. Higher than 7, then the soil is alkalinic. For crop production, we need the soil pH to be between 5.5 and 6.5. If that is below that, then that's where these heavy metals get released into the soil. If it is more than that, then you have another problem whereby other nutrients like phosphorus become inaccessible to the plants. So my results show that the pH ranges from all those places. We found out the pH ranges from 3.5 to 7.1. This means that the soil is very acidic to neutral. And then these low values for pH, we found them in 0 to 100 millimeters. Most of the scientists will say, if you analyze for heavy metals, you can concentrate on 0 to 100. But as I've said, me as an agriculturist, I'm looking at the whole topsoil. So if you look at from 100 to 300, then the pH are there to not improve, but the numbers started to increase. And then again 200 to 300, that's where you find higher values for pH. And then pH, I must say, if you study heavy metals, besides physical evidence, where you say the soil is being degraded by bare patches, chemically, pH is your first entry to analyze, because the heavy metals, like I've said, the heavy metals they become released at a low pH levels. So the heavy metals, we found that the most important premium is the one that is a problem in those soils. The values range from 0.65 to 1.13. According to World Health Organization, the permissible values must be 0.8 and less. But in this case, we found values up to 1.73. And on average, for the whole, for all the areas, we found the average is 1.13, meaning that those soils are contaminated by, the contamination equates to about 41%. Yeah, the study areas, as I've said, the average there is 1.13. So I've highlighted in red there to indicate that there's a contamination. And then the rest, the levels were found not to be at that level where there's toxicity. And then the LOD simply means the levels where it's low levels of detection. So if you analyze, you couldn't detect, according to the method that we used, we couldn't detect zinc and others where there's LOD. So what are the recommendations? We recommend that, remember I've said there are 3 methods that I've mentioned from literature. I said soil washing, immobilization, and phytoremediation. So my studies is mainly on phytoremediation. So the recommendation is that we use hemp. Hemp has about over 25,000. The literature says it has over 25,000 uses. So hemp is a family of cannabis, Cannabaceae. So there are 3: sativa, indica, and then the other one. So the difference between this one and indica, the indica is the one that we call is marijuana or marijuana. So that is the one that makes you high. And this one, sativa, it does not make you high. So, and it has a high potential to extract those heavy metals. And you must remember that cannabis, especially hemp, is cultivated mainly for fiber, for food, like seeds, pharmaceutical purposes, medicinal purposes. There are so many uses. Industrial hemp, yes. So, yes, I've already said the main groups, varieties is, yeah. So hemp has a great potential to fight, to remediate the soils in terms of heavy metals. So this fiber, industrial fiber, hemp, is not going to be consumed because remember I said if the plants absorb those heavy metals, then it stays in the plant itself. But fortunately enough, for hemp, you are not going to plant the cultivars that will be edible. It will be for fiber. So the research will be basically to look at I think we'll maybe choose 3 cultivars and then look at the one that has a high potential to extract those heavy metals. And from there, what we'll do, then we'll extrapolate those results and then to other contaminated areas. What is the impact of this, of the whole research? Number 1, while reversing the contamination of the soil, at least we'll have our land back, and the benefit of hemp production as an economic crop. I think we all know that hemp has been the issue of SONA and SOPA, but currently on the ground there's nothing happening. So it will be one of the advantages. While we bring back the arable lands, we also get into economic stream of hemp production. And then number 2 will be reclamation of the lost agricultural lands. I must say in Machabe, The study says we have lost about 102 hectares of arable lands due to heavy metals contamination, not degradation. It's chemical degradation by these heavy metals. So now I will agree with Naren Chabiling. If you have lost so many, that much of land, then I don't think you are still bread basket of the country. So the third one, decent jobs will be created. Remember, if the hemp has about 25,000, over 25,000 uses, so you can imagine how many jobs can be created through the value chain from production up until the end product. And then economic development and food security will also be claimed through this initiative. Ladies and gentlemen, if I conclude, we should continue implementing this phytoremediation in Machabeng, and then the next step will be to go to Kofifontein. Kofifontein, mostly we have lost arable land. The contamination is on grazing land. And then we should also get funding. I mean, if you look at the growing economics around the world, they invest on research, unlike us. So if we invest in research and then we base our policies on research results, I think we can move forward as a country. And then, like I've said, the outcomes of this research will be replicated elsewhere where there is this heavy contamination. Thank you.
Thank you very much, Mr. Joseph. It's all that we have, colleagues. Nature takes care of itself. So Mr. Joseph is employing nature to take care of nature. So that's wonderful. That's news for me. You know, as an economist, you don't know those kind of things, but they are worth it. Yes. Our next presenter would be Ms. Guguletu Zuma Netsiukwi. I hope I'm pronouncing it quite correctly. Ms. Guguletu is an meteorologist. Yeah, meteorologist at Agricultural Research Council. With experience in the field of applied and extension agrometeorology. She uses her knowledge and experience to support informed decisions making in agriculture fraternity, from farmer to policy challenges, policy development. She has excelled in integrating knowledge domains to address agroecological related challenges triggered by the changing climate. She has expertise in climate monitoring instrument, climate data analysis, crop modeling, and community engagement. She contributes in knowledge generation and has published about 32 scientific manuscripts, dissertations and books, contributions, and a book. Let's welcome Mrs. Guguletu to the stage. I hope she can also assist us with rainfall in the Free State.
Niyaphila. ngiyaphila nami. Hey, wahlula indoda. Ladies and gentlemen, my name is Gugulethu. I am Zuma Nechi Ukwe. I'm not related, but I know the man. I'm an agrometeorologist. It seems as if it's a discipline that is not well known to other people. I became the very first woman in South Africa to be awarded a PhD in agrometeorology. Up until this moment, unfortunately, our youth has not seen or recognized the importance of agrometeorology. But I hope I'll share my expertise today so that you'll encourage your younger ones. I tried with my son, I failed. I was like, no, Mama, so much data. No. In agriculture, we rely on natural resources, starting from the soils to the atmosphere, and understanding how it influences the plant, how it influences the animal, and how it also influences the environment at large. But we don't only stop there. With the climate change, the atmosphere is changing, and the other spheres to the sun, I'm not going to name them. Just refer back to your old geography. The purpose of this presentation is just to highlight the challenges that are faced, which are elevated by the changing climate. We also want to present agricultural strategies that can be adopted within the Free State proximity, on ensuring that there is sustainable food security, there is processing value chains are in place and are compliant, and also to accelerate the economic development for the province to alleviate poverty. We also, when I did my PhD, I worked at Muteo and at the Southwestern Free State, which includes your Bloemfontein, your Tabanchu, and Botshabelo, and some part of the Bainsvlei. I interviewed farmers. When I went there to talk to the farmers, we discovered that none of them had access to scientific weather forecasting or seasonal predictions. So the concern was, okay, what do we use? As a rural Zulu girl, I know what my great-grandmother used to the indicators that she used to identify the days for planting, for weeding, and also for taking not the tractor, but the bulls and the plow to the field to plant beans. So I asked the farmers, what do you use? And then they presented a plethora of indicators that they utilize. It became a chapter in the thesis. So now we have realized the importance of integrating knowledge systems, not only to rely only on science, but also on the indigenous knowledge. And also we're looking at different approaches that will assist for adaptation as well as mitigation during the changing climate. And this type of research and the requirements within the agricultural fraternity, it requires inter and interdisciplinary. Your mic, your mouse. It doesn't move. Okay, so the aims of this study is to make sure that we create adaptive capacity for our farmers at all levels. According to the extension framework, we have different categories of farmers. I hear some of you are still relying on emerging farmers and all those terminology. But according to the framework of South Africa, we've got subsistence, we've got smallholder, we have we have commercial at small scale and larger scale. We also have agro processing category. So we also want to make sure that there's an increase in agricultural production as well as income generation, and also to make sure that we lessen the emissions of the greenhouse gases. in the platforms where we share the little knowledge that we have on climate change and weather and climate, most of the time people will be saying, you guys are talking about climate change, it's just a buzzword to source capital for the project. I just want to provide a brief history on how climate change was recognized. It started as early as in the late 1800s. See there? That's when they observed the changing in the atmosphere. It further, around about 1938, the carbon dioxide concentration in the atmosphere was recorded a little higher than normal during the average calculations that they performed at that particular time. In 1956, there was evidence on the theory, and then they developed the carbon dioxide theory of climate change. And then, around about 2017, all of us, the eyes were starting to open that something is really happening. And the effect of global warming, which was exacerbated by the effective radiative forcing, which actually talks about the cooling and the warming effect in the sky. That was in 2017, and then you know about the IPCs and the agreement and all the agenda that they've developed. And also it shows that for the past 20 years, they have also realized that the atmosphere is actually really warming up. Why are we experiencing the changing climate? It's because of the green gas emissions that are occurring, which are human-induced. Some, they occur naturally, but most of these is because of the human activities. The gas we're referring to here is the carbon dioxide, the methane, and the nitrous oxide. And the most contributor is the agriculture within our sector is the agriculture as well as the forestry. I'm going to remove this one. And what we have said, and there's a speaker who spoke about the agriculture moving away. I found it very interesting that we've got different terminologies of explaining these things. According to the predictions, it has been shown that the agroclimatological zones will be shifting to the east. It means the Free State, we know it's hot, it's cold, but it is going to be more arid. It's going to be more drier and more hotter, and most of the crops that we are producing currently won't be suitable to be produced anymore, unless otherwise the scientists come up with other cultivars which will be suitable for those type of climatic environments. So the targets linked to environment is to leverage the climate resilience and to curb climate change effects. Under goal number 13, there are different targets as listed there. I'm not going to specifically go through them, but I will address them in the coming slides. This is the global warming and the greenhouse effect. What actually is happening here is that the radiation from the sun, it's irradiated to the Earth's surface, and the inversion layer is generated because of the gases that we produce from Mother Earth. Some of the sun rays are trapped. They cannot re-radiate back to the atmosphere. They are trapped, and then that causes the blanket around the Earth, and then it increases the temperature. Is there a way you can reduce this? The percentage here, I can't see some of the things. I don't even know the subject. Oh, okay, thank you. So there are different pathways in which climate change affect resources. Let's make an example with the livestock. For example, land use and systems, they are predicted to change, and that can lead into the different compositions in animal diets. So if the animal diet is affected, it means the smallholder farmers will have to adapt to the changing and also get the strategies to be able to conserve and preserve feed which will be suitable for livestock. And also it will contribute into the change in the primary production of crops, of fodder and rangelands. And also the predictions are indicating that there will be a need for the change of the species that are produced in that particular zone. And also the quality and the type of grass or pasture that will grow as the climate is changing. It shows that more C3 plants, which are your wheat and your rice, will be more conducive. So it means even the diet of the livestock will change. I know horses they can consume rice and wheat without any problem, but it's not common for the sheep and the cattle. So those are the changes that will occur. It means the species they will be dominated by the C3 plants. And also in agriculture, the changing climate is coming with lots of different extreme weather extremes, such as drought, reduced or erratic or irregular rains, the floods, the outbreak of pest, the manifestation of different disease, even the disease that we are not used to within the province, and also the high temperature in South Africa and less rainfall is predicted, which will limit the water resources and which will also affect the soil water content, leading to decreased croplands. It is. And also maize production, which contributes to 36% majority of the gross value in South Africa. In South Africa's field crops, and has experienced negative effect due to climate change. And it's not only climate change, there are many other factors which affect the low production in maize, such as the farms that were used to be farmed and that they are no longer utilized. And also it is predicted that in South Africa the temperature will rise. By the mid-century it is expected to range from 2 to 3 degrees, and then in the later intermediate scenario, it's shown that it can escalate to 3 to 4 degrees Celsius. I hope we don't get to that. Methods and materials. Ladies and gentlemen, there are different instruments that we use, and methods and materials within the field of agrometeorology. For example, we use combustion analyzers based on different measurements that we want to measure or collect for carbon dioxide and other chemical or gas emissions. We also use data which is retrieved from different satellites. This one is a UMISAT, which is mainly used for forecasting by the South African Weather Service, which provide 12 channels temporal within a space of 15 minutes, and it covers the whole of Africa. We also have radar, which is a real time, which provides the atmospheric conditions at a space of 0 to 6 hours. There are also other models that are used by SOS for forecasting and also prediction. Sorry, the technical issues in here. Can we borrow the stick? So why is it not moving? It has moved from it is dead. Let's go again to it. It was moving, it is dead. Let's go to the presentation. Okay. Apologies for that. So we also have automatic weather stations across the country. This is the distribution of weather stations that we have. And keep in mind, these weather stations are only for agricultural use. They operate at a microclimate space. And let's zoom in into the Free State. This is our Free State. You see the extent of the Free State is almost 130,000 square kilometers. But the agricultural ones, which are controlled and monitored by the Agricultural Research Council, they only amount to 46 automatic weather stations, and 6 of them were removed because of vandalism. And we wish to have an increment of at least 40%, which will amount to about 80 units. I'll show you where the station is still going there. But this is, if you look at this map, we can do better as a province. There's an annual data, rainfall data that I'm going to share. That's where the station was installed in 1922. Today, I am able to stand here and confirm that even at local level, the weather station is installed at Glen. I can show with the scientific evidence that climate change is also affecting us here in Bloemfontein. We will get to that. This is a weather station which is installed in Estel. It's in the Free State. If you look at that unit, it can amount to about 85,000 rands. And as our colleagues were talking about the agricultural operation instruments, this is one big opportunity. Each and every unit or sensor or instrument that is here, we get it from Campbell and they are located internationally. Can't we manufacture our own sensors? Food for thought. Let's continue. We also, as agrometeorologists, work within the field of biometeorology, where we look at the function and the productivity of a livestock. And this one is micrometeorology, where we look at the interaction of the climatic parameters within the planted agroecosystem. If you look there are different sensors in that white. It's that white frilled instrument. It's called a Jill screen. You can see there's a wind speed and a wind direction measure, and we measure at different levels to understand the leaf expansion of different crops. The same method is used for forestry and also for horticulture. We are also involved in crop modeling. There's a lot of skill in the Free State. It's just that we don't know each other. This is Aqua Crop 2. I was one of the first people to be trained to run this aqua crop. We use it, the main elements that are required, as you can see. It's climate, it's crop characteristics, it's soil types and soil properties, and also the agricultural practices at that particular level. And then at a specified area. With this information provided, we are able to generate different scenarios on what to plant, when to plant, how to select the planting date, and also to even forecast the yield for that particular crop. This is part of the study I did. It is the moderate catchment. I'm sure it's familiar with every one of you. It's used for identifying crop suitability. It uses temperature indices. If you can look at your legend there are different numbers. When you go into this model, you are able to identify the crops that are the crop types that are suitable for that particular area. You can see within this is where we are. We can see we can plant different types of crops. This is another one, we call it PEX. It's a model which we use to delineate the areas which are most suitable for rain-fed maize production. I liked your term. I can't remember who said this, the agriculture is moving away. Oh, I think it's my friend from the university. No. Actually, the way you explained it is the way I explain it to the farmers. That's why I was like, wow, it's very interesting. How is it moving away? You can see those are the agroclimatological zones. They differ in color, and you can produce different agricultural enterprises in those areas, as long as they are suitable. Whether it's your vegetables, it's your grains, it's your legumes, or your animal types or different breeds, you have to select based on the environmental requirements. The prediction, this was for 1980 up until 2016. The predictions are saying now it is indeed moving away, because you can see how the greenness, if you look at the green color, and it has moved away to the eastern part of the country. So what is that telling you? And also the water resources, the limitations, and the use of climate smart agriculture. At Weather Services, they tell you to be weather smart, climate smart. Here in agriculture, we talk about climate smart agriculture, we talk about knowledge smart, and all the smart that you can think of. We require the policies to include broader economic growth within the climate smart policies, and also to ensure that there is sustainable development goals which cover the agricultural fraternity and also the socio-economic development. And for the reduction of poverty and it has to be integrated with disaster risk management. When we talk about climate smart, it's about understanding the resources that you have in your location, and also understanding the soil requirements. Our farmers, most of the time, they don't take soil samples to find out what is lacking, what needs to be improved, whether that soil is suitable to plant or not. I remember I was let me just go there, not go there for now. Climate smart agriculture is a concept which ensures that we improve the crop productivity, and also making sure that we looking after our soils by minimizing tillage, improving the soil cover, ensuring that we leave the biomass on top of the soil so that we will improve organic matter on the soil, and reducing production waste. There are lots of concepts behind it. Such as this one. This is a picture which was taken in Tabanchu. You know the soils in Tabanchu are very high in clay content. This concept you cannot use at soils with at places with sandy soils. So what? Okay, let me just. They make dams and then they develop a slope. The water runs into the dams and then the water is stems in those dams that they create, and then they make ridges, and then they plant there. They can put mulch based on the type of the plant that is being planted, and this is just a schematic representation of what I'm trying to explain. I think visuals explain better than my words. So this is an example of a smallholder in Tabanshu. That each and every technology that is being used is not suitable for all the farmers. It's not one shoe fits all, no. It is based on the natural resources and what the farmer has been advised to implement or plant in that particular area. In this particular case, it has to be under rain. If a farmer is producing under rainfed and the soil there are your high clay content such as the swartland, the farmer is advised to utilize grey water, harvest off-road water if possible, and also apply mulching. It can be plastic. They can use plastics. They can use stones. They can use pasture from the pastures. They can use any type of material as long as it won't degrade the soil. And also, composting is very important to improve the soil, the top horizon, as my colleague has presented just before this presentation. And also, where our smallholder farmers are lacking is the access to weather forecasting information as well as seasonal predictions. And also they are lacking in the interpretation of that kind of information as well as the application. That is exactly where we feature in by the development of agro-advisories. This is just a schematic drawing to display or to share the different types of droughts that affect farmers. There's meteorological drought. If you can look there, it is categorized based on the duration, which occurs during a short time of dryness, and then there is an immediate dryness where agricultural drought occurs, and there's for a longer term of dryness, it's categorized as hydrology drought, which all results to socio-economic drought, which has an effect in the environment, the communities, the livelihood, the agro ecosystems, as well as the economy of the farmer, with just the livelihood and economy of the farmers. Having presented all the other information, we went back to the farmers to find out what have they noticed based on the rainfall occurrence. Have they seen any changes? What are their perceptions? Then we discovered that most of the farmers have experienced late onset. Most of the farmers have experienced poor rainfall distribution. And also they say that the amount of rains has decreased, and also the cessation of rains is late, and also that there has been, the rainfall seasons have become shorter than usual, and there has been a rainfall shift. I'm not going to talk on this one. I'll give it to my colleague just to save time. I want to jump to this one to show that the models that are used to predict, they are used mostly for rainfall as well as temperature. But you can see the bottom one, it indicates that most of the models that are used for prediction, they confirm that there is an increase in temperature. But when you look at the top one, which shows the rainfall one, there is no agreement within the models. This is the annual greenhouse gas emissions by sector. And where are we standing as agriculture? At 11.6%. And for carbon dioxide, we are sitting at 14%. And for methane at 4.3 based on these studies, and also for nitrous oxide at 15.1. This is the carbon dioxide emissions for fuel combustion. As a country, we are at 1%. I'm not going to zoom into those percentages for now. But what can we do in agriculture to limit, to lessen or curb the rate of the emission of these gases? This is a biodigester that is installed in Qwaqwa, right here at home in the eastern part of the province, where they are using the cow dung and the compost to generate the methane, and then it supplies the communities with gas for lighting, cooking, and heating. And then I just want to remind the House on the extreme weather events that happen within the Free State. Can maybe someone name one that you know it's troublesome? Don't say floods, it's already there. Heat. Look at that maize, it's showing the droughts. This field was taken right here in the Free State somewhere. The heat waves that are affecting the livestock, the crop production, and the farmers themselves. The dust storms. This is a picture from my colleague, my co-author. And the snow. Due to severe cold spells, the animals are also affected, and also the death rate increased based on that one, and the thunderstorms that are occurring, severe cold spells. I believe that the cold this season was the coldest, that is one of the coldest that we've ever experienced in the Free State, but we'll wait for the science to attest to what you are saying. This picture is a very sad picture, because you can see even when the farmers try to make fire to regulate the temperatures, but they lose stock. And also the lightning. Farmers, communities, animals have succumbed to lightning. Maybe you'll be reminded of the cases that happened in Butabelo. And the veld fires. Just this morning we received a fire index warning to say don't even strike a match, because the fires, our province is burning. In the first week of September, we counted around about, just 1 week, around about 6 fires that were happening across in the Mangaung Metro. Those were only for Mangaung Metro. These are the extreme weather events that we are facing. How can we be productive in agriculture when we are facing all these things? Are our farmers ready to be productive? This is my favorite weather station I told you about. It is at Glen Agricultural College. 100 years of data. This one I did it myself because I didn't want any problems. I didn't want to say, no, you didn't add this or deleted this. If there's a problem, I take accountability. If you can see, what is it saying? The variation of rainfall per year. So it means each and every year you cannot expect that you'll get good rains. There are good years and bad years, and there are worse years. If you can see, it shows that in at least the probability of getting an annual rainfall of above 1,000, it's only 1 in 50 years. We'll be reminded of the floods in 1988. Oh, some of you were not there. Do you remember how it disturbed the South African, the country, the communities across South Africa? And then if you can look at the red years, those are the worst years we ever received in the Free State, particularly in 2015. And then 1992 was the driest in 100 years. And we're going to zoom into this data. Now these are just the annual rains. These are monthly rains. You can see the trend. You know which month we usually plant. We use this data to advise the farmers to create the seasonal boundaries, and also to select the planting dates, and also to make sure that during the time of planting they will receive sufficient degree temperatures to sustain that particular type of crop and the cultivar. These are the SPCIs which we use, is a tool that we use to describe the dryness and the wetness within that particular area. And if you can see, 2015, that one, it shows the severe occurrence of drought in the Free State. If you want more details on this one, you'll get to the presentation, and also my colleagues. If you need to contact us, we will be available to give you more information. This is the annual rains per province. I'm going to pass this one, but you can see the eastern part of the country, of the province, is wetter comparing to the western part, your Fontaine, your Coffee Fontaine. You know how dry. That means to a farmer, what is produced in the eastern part cannot be suitable in the western part. Indigenous knowledge. The indicators that farmers use. I've done the science. Were you not happy? Let's go back home. They observe nature, they observe animals, they observe the vegetation, they observe the animal behavior, the vegetation, and the plants. For example, an indication of a drying aloe is shown to predict the drying conditions. I have not seen one because the El Nino has already been confirmed. They look at the birds' behavior, and then those farmers, they'll be able to make an agricultural decision, whether to plant, prepare the land, harvest, and all those things. I'm not going to go through this one. I don't know whether we've already experienced armyworms in that. I wanted to ask you before. Have we received the reports on armyworms outbreak? Not this year. Yes. But here they say if you see armyworms, that's an indication that there is a drought season. You said you saw it when? Last year. 2 years back. They say here it's showing that the drought season is imminent. So the farmers have to prepare for a very dry condition. This one we still need to validate, to find the scientific facts behind it. And also we wish to integrate all this information into an early warning a tool that will be utilized within the Free State. I'm not going to go through it. It's going to take, I know I'm very passionate about it because it's very interesting. However, the occurrence of the climate change, it's showing that there is seasonal shift, which means there will be early or late arrival of spring. There will be shifting in planting dates, delayed or short planting season. This one we've already spoken about. Why is this all important? It's because of the food systems within the province. The food systems, they relate into the complex activities within the agricultural system, starting from production to transportation to agro-processing and consumption. Didn't you have nice lunch? All these processes are involved, and it affects the societies, it affects the ecosystem as well as the national resources. That's why we have to work with nature so that we'll be able to be productive. This one shows the interaction between food production and also climate change, which climate change is also alluding into the rising of temperature, changing precipitation regimes, and increasing carbon print. And also, it talks to all the processes that are required within the food system. For the animal, okay, here I'm going to give an example for dairy and beef production. That's the production will actually decrease. I will skip this one as well. So in the past 4 seasons, we had excellent, good rains. In the Free State, I won't talk for the whole country. It means we were in a La Nina phase. But now things are changing. The La Nina phase can last to about 2 to 4 and even beyond number of years. These are the oscillations showing the duration of the phases that has occurred. You see the blue one at the bottom, which is negative, is showing the La Nina, and the red ones are showing the dry seasons, which is the El Nino. I'm not going to go to the process. The current stage and the predictions, we were told about the coming drying season as early as in March this year, but it was still weak by then, but now it is intensifying. According to South African Weather Services, they've already issued a seasonal forecast to say from November, December, January, there will be below normal rains in the Free State. So when there is a below normal rains, our responsibility is to contact the farmers and advise them on which scenarios to take. I'll give an example that it's most important that they lower the plant population. They adopt drought-tolerant cultivars. They increase the soil water. They choose soils with high water holding capacity. They provide sufficient drinking points for livestock, as well as the provision of shelter. And also selling some of the livestock, so that should it worsens, the livestock will not die, but at least they would have generated money than losing the whole head. And also I'm skipping a lot of them. The recommendations, we recommend that there should be an expansion of automatic weather station within the province. We also wish to be supported to develop tailored, integrated early warning systems which are specific for the Free State location. And also to integrate and document indigenous knowledge which is related to weather forecasting, seasonal predictions, as well as agriculture at large. And also to develop interventions for biodiversity conservation, management, and planning. And also to run trials for more drought-resistant dry crops within the Free State. I like what my colleague has presented. It's very impressive. We should continue with other crops as well. And also coming up with other methods to make sure that we restore the agricultural status within the Free State. And also we need to strengthen training and awareness on climate smart agriculture, global One Health and other approaches which are suitable for the Free State, especially for agricultural advisors. Colleagues, I think it's time we move from the brown growth into the green growth. I'm just gonna stop there. I am tired. I thank you.
All right, thank you very much, colleagues. Megugu, thank you for an enlightening presentation. I now know that nature and science are one thing and the same. It's just that we need to know how to be able to understand nature, because that's part of science. Yes, we will take the last presenter. Our last presenter is Mr. Oh, sorry for that. Okay, I just have a wrong biography here. Yeah, no, I'm checking. It should be somewhere here. Mekok, I saw your thing, but when I now try to look for it. next presenter is Ms. Kok Ngonyama. I can't find the biography. I'm not sure what's happening. But anyhow, Mengonyama would assist us in just telling us, oh, I found it. She has been a scientist for about 16 years in agronomy and working with the Department of Agriculture and Rural Development. She comes from the Northwest Province at Hositile Tola High School. She specializes with field crops. She's also a member of the South African Society of Crop Production, serves in the ARC Small Grain Annual Planning Committee meetings, as well as other departmental research, peer review in short. Let's welcome Kok Ngonyama to the stage so that she can also tell us about the science of agriculture and crop fields. Thank you very much.
This one. Let me take this time to thank the program director, May HOD, and all protocols reserved. Okay. I am going to present to you about a study that us as the Department of Agriculture and Rural Development have been doing. Now I think it's the 5th year. I would like to firstly give you a little bit of a background on the study that I'm going to present to you. It's a 3-year study that was conducted in order to achieve EXCO resolution of 2014. I was appointed as the project leader to implement this research study, and we approached a number of private seed companies as well as the Agricultural Research Council in order to get the accessions to test for ethanol production, as in the country we did not have a feedstock or a crop that is, or a sweet sorghum crop that is specifically bred for ethanol production. This study has started in 2017. In 2017, we did not have enough budget to carry the study on, especially in terms of certain analysis that had to be done in order to validate our study. Then I applied for funding to national, of which we were awarded the fund in 2021. And we had already been on the 3rd year of the research study, meaning finalizing the study that I'm going to present today. And then after receiving the funding, then with the very same objectives, we only changed the topic, and then we digged deep into the objectives that we were looking at. And then also the fund, we collaborate with the Agricultural Research Council Green Crops in Potchefstroom, as well as this university, the Department of Agriculture, Central University of Technology, whereby we are funding a master's student on the very same project. But she is focusing on a different topic regarding the plant nutrition part. Our collaborators, as I mentioned, are the ARC and the CUT, as well as small-scale farmers in the Free State province in certain districts that I'm going to speak about now, and then as well as the extension services within the province. So that is the little background that I wanted to share with you with regard to this project.
I'm going to present the first 3-year study that we conducted already, and we have the results, of which I can proudly say to the messenger who who brought this to me or chose me to lead this project that yes, we have the results. I understand that the reason for that or for this project, maybe one of the reasons was because the industry was supposed to be started in somewhere in Bothaville. And then apparently there was no feedstock to feed the industry. And then that somehow chased the investors away because there was no research that was done within the province that can assure them that they will get a feedstock from. So now today I can proudly say, and as well as with the second project that will be finalized next year, that at least we have a startup crop, even though the ACCI Institute, the Crop Improvement Institute in KZN, they are busy with improving the sweet sorghum cultivars that are currently available in the country to breed them specifically for ethanol production, and they are not yet released. I can say that at least from what we have, both in the market as well as ARC, there are some varieties with a potential to start. With that background, I would like to start with my presentation now. I am going to present to you the ethanol productivity of sweet sorghum with a scientific name, sorghum bicolor L. moyeng, varieties as a source of biofuel under dryland conditions of the Free State. I myself and my co-author, Ntate Chabeleng. This is how I structured my presentation. I'm going to firstly talk to you about the purpose of my presentation, the introduction followed by literature, aim and objectives, materials and methods, data collection, results, summary and the impact, as well as the recommendation, then the conclusion. What is the purpose of this study? The main purpose of this study was to provide solution to high octane fuel and energy levels through supply of sweet sorghum as an alternative replacement to fossil fuel sources. Sweet sorghum is recently gaining importance as a feedstock for ethanol production since it has been classified by the Framework for Biofuels as gazetted in 2019 as a reference crop. And with its juice stem containing sugar, it is a very good alternative for bioethanol production to meet the energy needs of the country. It can be grown under reduced inputs, responds to stress more efficiently, and has a large biomass production potential. So it suits a group of crops that needs to be chosen. Like my colleague, the one who just left now, Megugu, we need to look into crops that would not need, crops that can acclimatize to the current situation that we face of climate change, that can suit that, and then at the same time does not compromise the food security. So sweet sorghum can give that or those characteristics. The biofuel industry in South Africa cannot take off because it doesn't have the reliable reference cultivar sources to feed it, as I explained why we started this project in the first place. Once cultivars are developed, it means biofuel business enterprises can start up factories producing biofuels, in particular bioethanol. It is important to identify superior genotypes for ethanol production in terms of the BRICS content, which is the sugars that we look into mostly in terms of the parameters that we look into when we talk biofuels or bioethanol, as well as the total soluble sugars and ethanol production, ethanol yield. Now, what type of sweet sorghum we were looking for ethanol production? We are looking for a sweet sorghum that can produce a high biomass of about 30 to 40 total dry matter per hectare, and this means that that plant must have a height of about 3 to 4 meters. Also, we are looking at a sorghum that will have high accumulation of soluble sugars in the stalks. We're talking about the Brix content of about 15 to 20%, with 80% of saccharose, sucrose. We will know from the results if we have such sweet sorghums with that potential. And then also we are looking at the sweet sorghum with high energy value of the bagasse for cogeneration, which means more fiber with lignin. Bagasse is that fibrous material that is left after juice extraction from those plants. Also, that is now in terms of literature and research studies going on, they are looking into the second generation of ethanol production. This project serves as part of the first generation of ethanol production. Also, we are looking at the sorghum that is adaptable to marginal soils. And with marginal soils, we are referring to soils with high acidity, aluminum toxicity, and very low phosphorus levels. Previous studies has indicated ethanol production from sweet sorghum as cost effective. All this we want to carry out without sacrificing the grain for human consumption as well as for animal feed. The aim and objectives of the study the main aim of this study is to evaluate and identify the sweet sorghum genotypes suitable for use in bioethanol and bioenergy production adaptable to the free state growing conditions, to contribute towards availing suitable sweet sorghum cultivars for industrial ethanol production, and to address the drop in sorghum production based on availability of markets. Now, the first objective of the study was to evaluate the agronomic performance, varying maturity and morphology of 10 sweet sorghum genotypes as potential sources of ethanol and biomass production. And the second objective of the study was to evaluate the phenotypic stability and adaptability of sweet sorghum genotypes at different agrological zones in the province. To determine, which is the last objective, to determine the sugar accumulation patterns and sugar quality traits in the genotypes for ethanol production. Materials and methods. A field study was carried out in the Free State at varied locations. One trial was conducted at the Glen Agricultural Institute where I'm based, and it was our own station trial. And the other two trials, one was conducted in Botterville, on farm, at a farmer's field or at a farmer's farm. And then the last one was conducted in Kopis, in Fezile-Dabi district. And the study was conducted in a randomized complete block design with 3 replications. Sorghum was harvested at physiological maturity stage of development and evaluated for several stem juice production traits, which include the plant height, stalk yield, juice volume, percentage Brix, total soluble sugars, and ethanol yield. The experiments were planted during the summer season from mid-November to mid-December, from 2019 to 2021 growing seasons. Varieties were assigned to experimental plots which consisted of 4 rows by 5 meter length and 0.90 intra-row spacing. The planting was done using the seeding rate of about 12 kilograms per hectare planted at a depth of 5 centimeter, and we planted by hands. Fertilizer was applied according to the recommendations made on a soil test report for each location, and the plants were grown strictly under rain-fed conditions, and pest and weed control was done when it was necessary. Also, bed guarding was effected since we were dealing with a sweet sorghum which is liked by birds. So we did some bed guarding after the panicles were formed to prevent grain damage by birds. And here is a list of the varieties that were used in the experiment, and then 6 of them were obtained from the ARC, with 1 check which is an Indian variety, and as well as 4 commercial varieties or genotypes from seed companies. And then data collected. Emergence was observed in all plots 2 weeks after planting, and plant state counts were determined. Days to 50% flowering also was determined. At physiological maturity, all observations were taken in the 2 middle rows to measure the following: the plant height, which was measured from the base of the plant up until the tip of the panicle using a measuring tape. Second parameter was the sugar content in juice, which is called the Brix content or Brix percentage, which was determined by a handheld fructometer. And then the other parameter is the juice extraction rate, which was computed by taking the ratio of the weight of the fresh juice to the fresh stocks and divided by 100. The stock yield was taken from the weight of 10 stems, which were taken and weighed together to take a stock yield measurement. Then the stock juice yield was recorded as the mass and volume of juice after extraction, which was recorded in both mils and grams and was later on converted into liters and tons per hectare. The bagasse yield, which is the fibrous material I talked about, was also its biomass was also recorded. And then lastly, the sugar yield, which is the theoretical method which was used to calculate the total ethanol yield, what I can call the ethanol yield, but is theoretical yield, by the author, the Waterman et al. Now the results. The data was subjected to analysis of variance, the ANOVA, using the general linear model procedure of SAS. The LSD at a level of 5% significance was used to identify the homogeneous groups of values of particular morphological or productivity parameters. Also, the Pearson's correlation analysis was conducted using the very same software of SAS and was applied to describe the relationship among the morphology traits. And then the PCA analysis were also done based on the correlation matrix was performed using SAS to identify influential traits for selection. And also the biplot was plotted to show the association among genotypes based on observed traits. Now, these are the results for 3 growing seasons for temperature and rainfall we received during those seasons when sorghum was planted, and then they varied considerably during all 3 growing seasons. The total rainfall over the growing season was higher at Glen for the 2019-20 growth season and lowest at Bothaville for 2020-21 growth seasons. So with temperature, sites exhibited almost no difference. And then in terms of soil properties, soil samples were collected before planting trials at all sites, and the samples were used to determine what is available, but it was mainly for fertilizer recommendations. And then these were the results at all 3 sites. The pH, as my colleague has talked about, that anything that is below 7 goes to soils being acidic. The soils at Glen were moderately acidic, while in Botterville were both slightly acidic with a pH of about 4.5. And then I would say overall, the results for soil analysis came with a recommendation that lime application of about 100 kilograms per hectare must be done, but it was not applied in this study. Now, looking into the first parameter measured, which is days to 50% flowering, represented here on this graph, it's how the varieties performed in terms of days to 50% flowering. And as you can see from the table there, the mean flowering was highly significant and it varied from 71 to 106 days. And then Pan was found to be the earliest one among the rest in terms of flowering, while Honey Green, ARC 32, SS 32, and Bar Sweet took 106 days, which were the longest for to flower. Now with mean plant height, Banar was the shortest among the rest genotypes used, while cultivar ARC SS 27 was the tallest. And then the third one, which is the stock yield of sweet sorghum genotypes. The mean stock yield ranged from 5.97 tons per hectare, that is for Banar 8816, and it ranged from that to 102 or 103 tons per hectare for Honey Green. And the highest stock yield was achieved at Botterville, while the lowest was achieved in Poppies. Higher stock yield might be due to the expression of positive heterosis for leaf area and crop growth rate. Now the mean Brix content for sweet sorghum genotypes. The juice Brix recorded at physiological maturity varied from 5.27 to 21.4% significantly among the cultivars with a mean of with a mean average or with an average of 13.9. So among the tested genotypes, SS27 alone recorded significantly superior juice Brix and was on par with the best check, which is sugar grapes across all locations and seasons. Now with the mean panicle fresh biomass, the fresh biomass differed also across locations and seasons. The biomass ranged from 65.7 kilograms per hectare to 1,496 kilograms per hectare, followed by Honey Green, which was about 970.7 kilograms per hectare. The leaf biomass also, high biomass was obtained in ARC SS32 at Botterville, while the lowest was obtained in ARC SS17 at Poppies in 2020. The Bagas fresh biomass ranged from 5,481 kilograms per hectare for Pan to 49,222 kilograms per hectare for Honey Green. And then with the mean juice extraction rate, the mean percentage of juice extraction rate across location and season also differed significantly among the genotypes and their interactions with the locations and years. And the mean increase rate was observed with cultivar ARC SS76 at Glen in 2019 over ARC 44 at Glen in 21. So far, I'm talking about different cultivars, which shows a lot of variation in these cultivars, which may tell that the results or the cultivars performed differently, and they were not stable across all locations and seasons. Now with the stock juice yield, it ranged between 0.6 tons per hectare for pan and 17.61 in honey grain. And then the theoretical ethanol yield, the mean sugar yield was lowest with Panar, which was about 6.89 tons per hectare at Kopis, and 221.7 tons per hectare for ARC SS32, and actually 221.7 tons per hectare for ARC SS32 and 204.7 tons per hectare for ARC SS27. Now, in summary, the results of this study shows that sweet sorghum genotypes were affected by the location, seasons, and their interactions. And then high performance was demonstrated by the genotypes ARC SS27, honey green, and ARC SS17 in all parameters measured. The study further revealed that there are some commercial genotypes and most ARC genotypes have induced qualities and parameters for sugar yields. Botterville was considered the most favorable environment for both fresh biomass yields as well as sugar yields of sweet sorghum. This indicates that selection for plant height, stock yield, bricks, juice yield, and related traits cannot be carried out across all three locations, but selection has to be made and carried separately in each of the locations. The impact of the study, the germplasms are showing a good sign of performance in becoming the first most reliable source of non-fossil fuel source of ethanol that will leverage and blend a significant percentage of octane in our South African petrochemical industry. And the replacement of 1% basis point of octane by low carbon ethanol from sweet sorghum source will assist in reducing and mitigating the long-term effects of global climate change. Now, the study recommends that sweet sorghum genotypes showing good performance in trial parameters be selected for registration and certification with the relevant authorities for IP and distribution, since these varieties which perform the best from the ARC, and they are not registered and not released yet. So, but now I'm happy that as I collaborate with them, they are starting this season with multiplying those accessions in order to register, in order to select and register those varieties. Some of these varieties are used in my study, are included in that big project as well. A quantitative study needs to be carried out also for the high performing genotypes, which are ARC SS27, honey green, and SS17 be tested for cost benefits analytics on threshold of octane blending levels. It is important to consider the environment because they play a major role in determining best performance in production parameters. And it can now be concluded that the results of this 3-year study indicates that some genotypes tested produces sufficient amount of biomass, juice yield, and ethanol yields. Also, it supports the findings showing sweet sorghum potentiality for ethanol production, and this crop could play a major role in the emerging biofuel market. It was then concluded that the OPVs and hybrids identified from this study could form the potential donors for further improvement of sweet sorghum for biofuel production. and further studies of adaptability and stability in different environments and seasons are still important to obtain more complete information on the performance of genotypes in specific regions. I thank you.
Thank you very much, Ngonyama. That was our last presentation for the day. Can we just open up for questions and sessions? Our time is running very late, but we are almost there now. The next 10 to 15 minutes will be done. Can we open up for questions and answers? I'll start with Mr. Mngoma, then followed by Ntatempo and Dr. that side. Mpo, I'm calling you Ntatempo today. Did you hear that? It's fine. All right, Mr. Mngoma, you can start.
No, thank you, Chair. Thank you, colleagues, for very informative. Your presentation were indeed very informative. It's the first time I'm coming across such information. I don't have a question, Dr. Choman. I just want to confirm something. You know, in the past presentation, we were talking about this silo mentality that we have in government. And the presentation here that talks to Mezuma, the issue of the your climate change. I was sitting here, maybe with my colleagues there from budget, that normally every December we sit with National Treasury, and there's one with regard to your terms of reference, Dr. Shabalala. They always want us as provinces to indicate the impact of climate change on budgeting. And we'll be running around looking for this information in the province. Had we known that Mekuku is there, we could have gone to, we could have visited you and received all this information. You know, there's a new concept that is being implemented. We have not perfected it together, provinces and National Treasury. They call it, just check it now, they call it your climate budget taking. It's climate budget taking. So you use your budget in terms of trying to understand the impact of climate change in terms of government spending. What are the developments in terms of the climate changing, and how are we spending in those areas? But it also extends to the issues of infrastructure development. What kind of infrastructure we're developing? Are we still using the old method in terms of brick and mortar when the climate is changing, and which says to us we must change the approach in terms of the infrastructure delivery? Do we still build clinic using brick and mortar, or do we adapt to the climate change going forward? So it's interesting. I think the colleagues from budget, we must get the number of Zuma there so that we don't run around. Thank you very much.
Come to me, Mr. Mngoma.
But I also wanted to. I also wanted to understand just the clarity in terms of your study, the 3-year study that we have done, Mengonyam. How far, where are we in terms of production of sweet sorghum in the province? I know you were looking in terms of the location and so forth, but how are we faring as a province in terms of production of sweet sorghum, and in which areas? I might have, I know you conducted this study, but I wanted, my understanding is that when you started this study, we were already producing sorghum. So I wanted to understand in which areas, in which location. Thank you. Zuma, maybe if you can also just a bit explain, you touch a bit around the issue of Kwakwa, the gas. You said they are using the gas for cooking, and but you speed, if you can just give us more explanation on that one.
Thank you, Mr. Mngoma.
This one I'm going to be short because the two last presentations were the most complicated ones. Yeah, that is very complicated. But let me start, Leah Hantate. Where is he? Okay, the issue of decontamination of the soil with cannabis. How do we recommend who's supposed to lead the process? Would it be the private sector or the state or the partnership of both? Because one thing that I know is very expensive, even just listening to it. The process is very expensive, but it's really necessary. And it's the South African state, let alone the capacity, but able or willing to go that route. In terms of the mining rights requirements, that of the requirements are much clear. One is the social of the miners and environmental impact stuff. As they contaminate the soil and blah blah, and how do we hold them responsible that when they leave the area and the license or the rights get expired, they leave what they got as it was? And taking an example of the very same affected farmer nearby the mining area. The last speaker, I'll have to call you. I will have to call you. Thank you very much, but it was a good presentation.
Thank you, Chairperson. Mine is just a comment. Listening to the last three speakers, I think there's a lot or an element of injustice that happened. What I mean is that they presented the most valuable information, but I think they lost the audience somehow. And maybe there's a need for further engagement. Those presentations, I think, for various reasons in our province, we need that information. Therefore, I don't know, I'm just talking from a layman's perspective, that maybe there's a need for a further engagement where the modularity from speakers themselves can be gathered, and also engagements, and also an opportunity to practicalize. I think I bear similar sentiments with Ndate Mujanaga, that, you know, it's like we could have had the full day only on the three presentations, so that we can unpack the implications, what it means for a layman in a language. It's not like we did not hear, but there's a need for us to unpack the information so that we can bring it down, and also so that it can be in a position where we can be able to take home and implement. But those three, I think injustice happened in a sense that they came too late on a Friday. You know, you can cite all these aspects that you can cite, but there's a need for a follow-up on the three presentation. Thank you.
Thank you, ladies and gentlemen. Just before, I think I'll give to the presenters just before I give to the presenters to respond, let me acknowledge all the difficulties, the presenters going overboard in terms of time and all of those things. They are all on my shoulders. Let me acknowledge that one. In terms of what we have just said, Mepukunzi, I agree with you. I couldn't have a colloquium without agriculture. Mr. Ntabeleng can attest to that. He sent me one presentation. I said, Mr. Ntabeleng, one is not enough. Can't we find others? You must be having something. I'm very grateful that my persistence led me to, in fact, they were 4. Because of time, I couldn't put another one on fisheries. There's another one study on fisheries also. So Mr. Ntabeleng, you will respond. I cannot decide on what you should do, but at least now colleagues know that you got a lot of information. It's up to you to say, how do you now distribute or, make the people aware of the information that you have so that you partner with those that they can assist us. Yes. Colleagues, you are allowed to respond. I think where you are seated, I think you are very tired. I don't know who starts first.
You want to start or should I start? Oh, okay. No, I've got a mic, so I can start. I didn't present, but I presented in all of 3 of them. I'm sure you saw my name there. So in all of them, I'm a co-author and I'm a co-researcher. So there was a question. There was a question that was raised related to Ndade France. It was on cannabis. When Ndade was asking about though I heard him, he was actually mixed. He was referring to Magugu, but actually he was talking about France when he was talking about the mining rights and all that. So, but then maybe let me start by trying to assist on the issue of the last speaker, on the soils as well as who should really lead the process, in terms of rehabilitation. I think it was a question, somebody's question, yes. The reality is that the mining really should take the responsibility, the mining company, right? When you talk about soil rehabilitation. And for that fact, I believe, though, of course, remember the government, it wouldn't really gain much except taxes and so on from the mining companies. So even that study that we're doing in Virginia, the farmer is busy negotiating with the mining company. You see, the problem here is, this thing is so difficult. I'm sure you saw Magugu, one of the slides of Magugu there was where she was showing what you call sheet erosion. I don't know that, not sheet, sheet erosion. Erosion of wind, we call it sheet erosion. So you'll find that in Virginia, the mining is about almost 10 kilometers from where the farm is, but there's contamination, and there was no spillage. How? Through wind erosion. And when you look at those measurements, the profiles, the 100, the 200, and the 300, we find high concentrations of heavy metals on the topsoil, which simply means these metals were actually transited or transported through wind to the site. And the whole area, 103,000 hectares around those mines, is lost. So the land is actually not usable. It's what you call a kaput or a wasteland. So how do you then ensure that the person who actually benefited, you are correct, you benefit, but you don't care. So the rehabilitation methods, you know what NIMA says, what NIMBA says. NIMA, this National Environmental Management Act, what you must do, the requirements for you when you do your EIA, then what are the outcomes of that? What is it that you must do? So those recommendations surely are there, but they don't care. Well, now once they pocket the profit, and that's a problem. I'm sorry, I'm going to be a little bit, don't take me, I'm not a politician, I'm a manager, I'm not a politician. But we can't run away from these things. These are realities. So with South Africa, unfortunately, instead of, we just, I think Dr. Mogoena yesterday mentioned the issue of, that helium mining that is to take place in the very same area, by the way, Virginia areas, Welcome areas. And you ask yourself, Why only 200 million against, which the estimate is talking about trillions, by the way, about 3 trillions. Now, then you ask yourself lots of questions. Now the issue here is the land has to be rehabilitated, but the person who caused the mess, they must. I mean, why do you hold the government responsible to rehabilitate for the person that benefited, but the government did not benefit anything? For me, it doesn't really make sense. But at any rate, that's how we see it. And of course, we are agreeing with the farmer. And the unfortunate part is that, as it's mentioned, it's very costly. You know, the process, because there's, permits that must, for you to even deal with that. Remember, he mentioned the sativa. Sativa is not the indica, it's not the high one, but still it has the, what? It has got what you call THC. And that THC, that delta THC, if you smoke it at a particular, amount, you'll also get nice. You get nice. You get what I'm saying? So obviously, people, when they see Smatekwane, they will go there and harvest, and they will, and all the stuff. So it is very important that really the rehabilitation has to be done and must be done by the mining. But at the same time, it's not only that. You see, the dangerous part is that there is, people normally confuse it with what we call silicosis or something, that disease. But actually, that one is not, it's not that one. It's this one, the only longest word that you find in English, 45 character letter word, is called, because it's a dust, combination of a dust and the ash and other stuff, now heavy metals. And that is what you call pneumonia. It's a pneumono ultra. You must count the words now. Pneumono ultra. What did he say? Oh, sound. Okay, ultra. Then it's also silico, volcano, then coniosis, something like that. One word. So it's a problem. And it's because people are inhaling this dust. I spoke about this problem. So the question was just only asking about who rehabilitate. But it's not only about the rehabilitation. It's also about the life, the health of the people around Virginia and Odendaal and all those places. They are in danger because of that problem. So it's bigger than what you see. But then let me not go too deep, otherwise you'll get threatened, because even some of us, that wind is coming here. You don't know whether you already have got that long name thing with you. So I think for the issue of Ndate, he spoke about the infrastructure, my boss here, Treasury. And of course, Treasury, we are also looking for the fund, but I know that we don't have money. We don't have money. But you also asked the question here related to, if then related to climate change, you will add value, and say, if then we are developing infrastructure, why then are we still? And here we also link to the very same cannabis, by the way, because if it's able to do more than, we know it has bricks, we do bricks with the very same, the brick, but it's talking brick and mortar, but there's houses that are built from the very same cannabis. So there's lots of byproducts and products that can be produced from that. But again, yesterday when you then link that question of my brother with the MEC and say, do you still need some of these things and so on and so on, whereas we can do, distance, whatever, and mobiles and so on. Yes, we can create mobile clinics with the very same sativa, whatever. So yes, I agree with you, my brother. We don't really need to go back to the brick and mortar. Technology is very advancing. So in short, I was just trying to add value to those two, and including Ndate on mining and social impact. So I think I've covered, but Matutu and see if you want to add, they can add. I'm sorry if I've taken your, but you can add. Yeah.
Thank you, colleagues, for the question. I just want to thank you for the opportunity. At least now people, they know there is a climatologist at Glen. And the only question that I receive is on biodigesters. Biodigesters are the units that we implement at farm level. The only reason for implementing these structures is to curb the rate or the amount of of greenhouse emissions, your methane, your carbon dioxide, your nitrous oxide. How it has got two chambers. In these chambers, we throw in the biomaterials such as your cow manure, your goats, your sheep, and the compost from the farm, and other materials which are digestible. And then thereafter, it goes through a process of, it goes through an anaerobic process. At some others, they do go through an aerobic process where the bacteria, they digest all the materials and emit all the gases that are not allowed to be released into the atmosphere. And then we channel these gases through a pipe into the house. And it's connected directly into a stove. And right now in South Africa, we are busy looking at ways of packaging these gases, like the way the Easy Gas, they package the gases through the gas jars. That is what the biodigester. Thank you.
Mine is simple. In the question on the locations which were used in the study, I thought that I mentioned that, but it was Copies and Bothaville. In terms of municipality is Nala and Machabe, yes, Machabe, and at Glen. So in terms of districts, usually Buzwa, Mangaung, and Veziledad. So now with the new study, which will be finalized this coming season, we've added the western side of the province the eastern, yes, the eastern part of the province, which is Wadin. So that is the only location we added to the whole project, as well as Potchefstroom, but which is the northwest, but one may argue it's not Free State. But in terms of climatic conditions, we thought that it's similar to the climate in the province, so we can add that. So in total, we have about 5 locations.
Currently, we are producing sorghum in Free State, but the sorghum that we are producing is not this type of sorghum. It's what you call sour sorghum. So we are talking here about seed sorghum, and that's why even that name is say sorghum bicolor Mwench L. Yeah, it's its name. So yes. So so in short, we are producing this sorghum by farmers. But let me hasten to say this. Particularly around that area of Bothaville or the northwestern part. It used to be the belt. The soils there are very, in some areas, especially towards Copies, is what you call Rensburg's black soils. And those areas are the ones that actually other crops don't grow better. But the very same sorghum is the one that is doing well. That's why we also tried around Copies and Glen, because also Glen, or let's say around Bloemfontein, because Bloemfontein up to Tabanchu, the soils are also very clay. That's why you saw Dr. Gugu there. She indicated the Matangwana. You saw those areas where there's Matangwana, you know, where there's, yes. So this kind of a crop that we're talking about is not being produced currently. And it doesn't actually interfere or because they call it a reference crop. It's a crop that has been identified that will not interfere with food security. Because if then we go for maize can also provides a lot of energy and sugar. But we can't go there because now it's competing for national as well as household food consumption. So it's a problem. But with sweet sorghum is meant for sweet sorghum is meant for animal feed generally. Hence, then we said, okay, this one, because it doesn't have a problem, the national approved it, and it's the only study that we are doing in South Africa which has not been done. So when we talk about the biofuel industry, we know in the east, in Eastern Cape, Kumha area, they are also doing their own study, but it's not, it has nothing to do with this one. It's not even about sorghum. I'm told it's something else, another crop. So, but then in South Africa, there's no crop that we can now say we have tested and is registered, and you can go out there to the market and say, this is the crop that we're going to go for the industrial biofuel to blend our octane content that is causing problem with carbon monoxide. We know it's the one that is causing climate change. So we are trying to be part of just transition energy. Thank you.
Ladies and gentlemen, thank you very much for questions and answers. Mr. Nchabeleng and your colleagues, thank you very much. It's well appreciated. I have learned a lot of things. I now know that there is an El Nino. I can even explain what causes El Nino. Yeah, and El Nino and the opposite one. I just forget the La Nina. Yeah, the other one is drought, the other one is a lot of rainfall. So thank you very much. Ms. Shabalala, can you just, before Ms. Shabalala can just give us the closing remarks, let me just assure colleagues that the presentations will be shared to as many as we can. Those that, if you want the presentation and you couldn't find it, just try to find my email. It's chomani@treasury. Then just send something. I'll be able to respond to you with the information that you are so much have been waiting for, that you have been here for 2 days. And I know I've taken a lot of you guys' time, but it's worth it at the end of the day. It's not for me, it's not for you, but it's for the betterment of the province, so that I can be able to have a report that we can say, let's all of us try to put something in taking the Free State forward. Thank you very much. From myself and my colleagues, thank you very much. It's well appreciated. Thank you.
Good afternoon, everyone. I know you are very tired. However, for the period that I have spent here, I have observed that there are real researchers and they are what we call ziwapi. But Ntate Mujanaga has also proven me wrong. But there's also another category of a mixed breed who can do both. He has committed that he's going to take the discourse around what we've been learning about to Kayla K. So that's the mixed breed. That was on a lighter note. I just came here towards lunchtime thinking that I was gonna only hear about 2 presentations and that the colloquial was ending, only to find that I still had a lot to learn, and I thank you all. Without any waste of time, on behalf of my colleague, HOD for Provincial Treasury, Memas Chaba Sising, allow me to convey this brief concluding remarks for the colloquium. As we draw the curtains on the 2023 and the 6th Free State Colloquium, I'm honored to stand before you not only as a doctor of business management, but also the newly appointed accounting officer for the Department of Community Safety, Roads and Transport. This event, organized under the capable leadership of the Honorable MEC Brown, has been a beacon of enlightenment, loaded with ideas, and a testament to our unwavering commitment to the brighter future for the Free State we want. The theme for this colloquium, thinking beyond the current economic challenges towards sustainable economic growth and development, touching the lives of ordinary citizens has been a guiding light throughout our deliberations. We've explored critical themes from inclusive economic growth and development to ethical and decisive leadership, from addressing youth unemployment and skills development to embracing innovation and technological progress, and finally, from harnessing alternative energy sources to power our sustainable future. Allow me, moderators for the day, to express my interest in all papers presented during the 6th Free State Colloquium, each offering valuable insights into the pressing issues we are faced with as a province. However, I would like to highlight the exceptional importance of Dr. Pugunsi's paper, Inculcating Network Governance and Cooperative Leadership. Dr. Pugunsi's work resonates deeply with the themes of this colloquium, which means it's cut across. In pursuit of inclusive economic growth and development, ethical leadership, youth empowerment, innovation, and alternative energy sources, the concept of network governance and cooperative leadership is central. It serves as the connective tissue that binds together these vital sub-themes. The idea of fostering cooperation and building effective networks is not only essential for addressing the challenges we've discussed in this colloquium, but also indispensable for implementing the recommendations that have emerged from this event. Dr. Pugunsi's paper, I believe, holds the key to unlocking the collaborative potential for transforming ideas into actions, which is, while I was listening, what most of the participants were raising. I also want to take a moment to express a special appreciation to Ms. Khabele, who, as an intern at this year, has made a remarkable contribution with her paper titled The Government Debt and Fixed Formation Nexus. It is truly inspiring to witness the dedication and talent that young professionals like Mekhabele bring to the table. What makes her contribution even more commendable is the uncertain future she faces as a contract worker. In the face of such challenges, her commitment to research and her willingness to share her insight with us today is a testament to her passion and her resilience. Let us now allow these discussions we had today to fade away as mere words exchanged in the confines of this hall we are sitting under. The true essence of our gathering lies in the actions that will follow as challenged by the Honorable MEC. The recommendations born from these discussions hold the potential to shape the destiny of our province. They are not merely suggestions, they are seeds of transformation waiting to be sown. Honorable MEC Brown had challenged us to find innovative solutions to the pressing service delivery issues in our province. This challenge is not to be taken lightly. It is a call to arms, a call to take the insights gained here and turn them into tangible improvements in the lives of our vulnerable communities. As we depart from this colloquium, let us carry with us the knowledge that we are not just as passive observers of the challenges facing our province, but active architects of its future. Let us pledge to use the recommendations generated here to influence decision-making at the level, such as EXCO level, where they can catalyze real change. In closing, ladies and gentlemen, including our virtual participants, I extend my deepest gratitude to all of you, to all the speakers and organizers who have made this colloquium a resounding success. Together, we have taken a step closer to a free state where economic growth is inclusive, where leadership is ethical, where youth find opportunities, where innovation thrives, and where alternative energy powers our progress. Let us march forward with purpose, for the journey towards the better tomorrow has begun. I am aware that the event went beyond the budgeted time, and your willingness to stay and contribute is greatly valued. Tate Mujana, your time at KLK is still waiting for you. Nevertheless, thank you. May the spirit of innovation and collaboration guide our path ahead. Thank you.
Ladies and gentlemen, the colloquium is officially closed. Yes.